Welcome to Mr. Kritzinger's video lesson based on quadrilaterals. As we already know, a quadrilateral has 4 sides and 4 angles. We are going to investigate and revise the various quadrilaterals and their properties in terms of side lengths and angle sizes. So the first one we are going to focus on is the parallelogram. For a parallelogram, we see that both pairs of opposite sides are parallel. So side AD is parallel to this other side. We indicate it by the arrows. Furthermore, the other side is also parallel, so these two red sides are parallel to each other. What we also notice is that both opposite side lengths are the same size. So the blue lengths are the same, the red lengths that are opposite each other are also of the same size. Then the angles that are opposite each other, they are also the same. So this angle and this angle equals each other, and this angle and that angle equals each other. So angle y and x can be of different sizes, they don't necessarily have to be the same, and the red side and the blue side also don't necessarily have to be of the same length. Next we focus on our rectangle. So for our rectangle we have again parallel sides. The blue side runs parallel to each other. The red sides also run parallel to each other. Furthermore, the blue sides are of the same length, so opposite sides are parallel and of same length. The red sides are the same length, so also parallel and same length. And again, the blue lengths and the red lengths don't have to be the same. All the angles of a rectangle are 90 degrees. Next we focus on the rhombus. For the rhombus we have in fact all 4 the sides the same length. So PT, TR, QR, PQ, they all have exactly the same length. The opposite sides, these red sides, they run parallel to each other. The opposite blue sides also run parallel to each other. And then again the opposite angles are the same. So angle P and R are the same size. Angle T and angle Q are of the same size. And angle P and T are not necessarily the same size, just as angle Q and R are not necessarily of the same size. Next we focus on our square. The square, just as the rhombus, all the sides are exactly the same, so all 4 sides the same length. And also as for the rhombus, the opposite sides are parallel. So the blue side JM runs parallel to KL. The red sides JK runs parallel to ML. And in this case, other than the rhombus, all the angles are 90 degrees. Next we focus on the trapezium. For the trapezium we have one one pair of sides only that are parallel. We get a very specific kind of trapezium called the isosceles trapezium, where the sides that are not parallel, in this case T and R, and P, the P side, they are the same length in the case of the very specific isosceles trapezium. But in general, trapezium, the only characteristic that you need to know is that one pair of sides run parallel to each other. And then lastly we focus on the kite. So for the kite we have the symmetry line in the middle, so in other words, to the right of this line and to the left of this line is exactly the same. That's why the size of this UV line in blue equals exactly the side length of VW in blue, and also why the red size UT is exactly equal to the other red side WT, and obviously VU and UT is not necessarily of the same length. The opposite angles on opposite side of the line of symmetry are also the same, so angle U and angle W are of the same size. This concludes Mr. Kritzinger's video lesson on the line, or rather the side and angle properties of quadrilaterals. Mr. Kritzinger wishes you a fabulous day. Goodbye.